I'm here to talk about technology change driven by machine learning. So I'm going to talk about a few different examples, but I think it's fair to start with the fact that the world is changing. It's changing very fast. The big will not beat the small anymore, and it will be the fast beating the slow. It's a great quote. I'm going to talk about 3 examples that I think everyone in this room can resonate with and understand. Who's been in New York City lately taking a taxi cab? Does everyone understand like how the medallion system works in New York City? You buy this plaque that sits in the window, and for a long time, they were very, very, very valuable. Just to get the numbers right, in 2013, a plaque sold for $1.3 million, right? Last year, or last month, I should say, one sold for, no one care to guess? $241,000. That's a decline of 1/5, right? And that change is driven by one thing, ride sharing. And ride sharing outnumbers taxi cabs in New York City 4-to-1. Why is that? It's because of the ease of use that goes along with that. You can click on an app, it knows where you're going, it knows best where to pick you up, and that's driven by machine learning. That machine learning has the intelligence to be able to say, oh, you're going here because I know on Fridays you go to the airport. That's change. Record stores. When's the last time anyone went to a record store to buy a CD lately? You did? Really? You're one of the few, by the way. In 2006, after Napster, I was one of the people that was downloading music from Napster, I'll be honest, because I thought it was the coolest thing ever, because I could get the one song. The record industry was still making $9.4 billion a year, right? Last year, CD sales, I want to take a guess? $1.5 billion, down 84%. It's not just the iTunes single purchase, it's the streaming music, right? The ability to have personalized music. Every morning I get up for a run, Spotify knows these are things that I want to listen to. That's all driven by machine learning. And it's an interesting thing to think. It's not just because I like this song and Bob liked that song, that's the song that I would like. Because if you think about if you have a new song that comes out, Bob hasn't liked it, so there's no correlated data. It's driven by machine learning. I still love to go to the movies every once in a while. My kid loves to go to the movies, so I get to do that. Movie theater attendance is down to a 19-year low. That's shocking to hear too, right? And that's driven by Netflix and streaming movies to the house. Again, it's a personalized experience. They can recommend what good movies you should watch, and I don't need to pick that out. I didn't know this. I heard this yesterday. I was talking to a friend of mine that's deep into the machine learning field, and he actually said that Hollywood is using machine learning to pick which movies to make now, because they're trying to figure out, well, if these movies are popular and be successful, it's not like build it, they will come. It's build it because we know people are going to want it. All of these changes are driven by a few things, and technology is a big part of that. We used to have traditional data centers. Has anybody read the book, The Big Shift from Google to Edison? It talks about the commoditization of electricity driving the Industrial Revolution, much like cloud is driving the new revolution that we're seeing. Infinite access to compute capacity on demand with no barriers to entry are going to drive the next revolution. Fintech startups, Uber, Netflix, all driven by that because you have to have no money to build out a big infrastructure. That's change, right? And that's really what technology is driving with this change. So what is machine learning? So as I was preparing for this, I thought I'd ask the really, really smart people in my life, what is machine learning? So I started with my 8-year-old, because he seems to know everything. And he said to me, I asked him, what is machine learning? He said, computers that make you smarter. Well, he's probably actually not that far off. One of the examples I'll talk about in a minute, the CEO of one of our fintech startups called it a brain extender. I think it's a great example. I also asked his buddy, Aaron, what do you think machine learning is? He said, it's a computer that will play soccer with me. Well, I was kind of like, I'm not really sure I believe that, but actually he's not too far off. Because we've seen machine learning leveraged in things like Go and checkers and chess. And that's because computers don't get bored playing the same game over and over and over again against themselves. And they get to learn, right? I'm a little more of a simplistic individual. I said it's answering questions using examples or many examples. If you think about it, we'll break it down a little bit. How do I go back? Back. We can break it down a little bit. We talked a little bit in the previous presentation about it being a field of AI, and that's exactly what it is. But it's a way of solving complex problems without having to codify the solution. Are there any developers that know traditional programming languages in the room? Yeah, a few. And the way that that works is it flows down like a river, right? Going through if statements and for loops and coming out with an answer. The way that ML works, it's a way of building systems that improve themselves over time. They get better, right? Like in the Go example, when the computer was playing against the Go champion, it made a move that they thought was insane, but it was something that the person hadn't been able to think about because it was outside of the way that they would think, right? To be able to have successful ML, you need to have three fundamental things. We talked about this a little bit before. Large data sets. Good models that get trained by those data sets, and tons of compute. And if we think about those things put together, where would you do that? Not on your laptop, not in your garage, but in the cloud, right? The ability to have infinite access to compute, to be able to quickly and efficiently and cost effectively drive machine learning is really what we think the cloud can bring to bear here. Eric Schmidt and our internal researchers talk about creating the AI loop. We talked about data. Data is not always easy to get, but if you crowdsource data, you can quickly get large amounts of data. And if you were to accumulate that somewhere, a great place would be the cloud, right? Storage is cheap in the cloud. You could analyze that with ML, take action, repeat, creating the flywheel effect that makes those models better and better and better and smarter and smarter. These platforms are the next trillion-dollar enterprise. I don't know exactly if you added up Uber plus Netflix plus Spotify, what that number would be, but it's probably close to the trillion-dollar mark, right? If you think about what the value of those things are in the future. And it's amazing how disruptive that can be. If you think about what those industries were before, record industries, taxi cabs, that's disruption in the marketplace that can be applied to any industry, whether it be manufacturing or financial services. It's disruption. So let's talk about a little about the power of adopting ML. Over the years, I've seen this trend happen. I've been in the IT industry for a long time, and traditionally they would come to us with a problem. We would talk to procurement and the traditional IT buyers. They would go through this process of laying foundation and buying infrastructure. They would operationalize it, and then they would go into production. The interesting change we're seeing now is line of business owners coming directly to cloud providers and going directly to production because they can't get what they want from IT. It's too expensive. The barriers to entry are too high, and they've been told no. And sometimes they just say, forget it, we're going to the cloud, and they do it. And then they prove success. And then core IT comes back and says, this is a black eye, and I have to get it fixed because they need to catch up. But that going directly to production is something we see very, very frequently. So I'm going to break this down into three categories. I guess this group being financial services, the Wall Street examples will have some interest here. Has anyone heard of a company called Kento? Show of hands, a few people? Yeah? Kento is a high-end analytics platform for financial services. They use TensorFlow, which is our open source machine learning framework to do that. And I mentioned this before, the CEO called it a brain extender. And not to mention, they were evaluated a couple months ago at $500 million after 4 years of being in business, right? $500 million. What they do is they use these models to predict what's gonna happen. So if oil price, I don't even know what the price of oil a barrel is today, but if it was to go up 25% today, there's some downstream correlation to what would happen to airline stocks, right? Because they're very reliant upon fuel. And traditionally what would happen is they would go to their quantitatives or quants, and the quants would go to a boardroom and they'd sit with spreadsheets and they'd crunch a bunch of numbers and in days or hours or weeks come back with an answer. I heard this expression a couple weeks ago and the guy called it Hippos. Anyone heard of the expression called Hippos? Highest paid person's opinion. It's an interesting statement. So what the idea of using machine learning to predict the response reduces the reliance on hippos. And we can use machine learning as a brain extender to not just rely on expensive people's opinions. We can base it upon fact and data and real outcomes. SunGard came to us last year as part of a request from the SEC to build the consumer audit trail. There was a thing called the flash crash. Flash crash, everyone know what the flash crash is? And what they were trying to do was ingest all the daily transactions that occurred in the US financial markets in a day. Well, if you think about how many that is, I'll give you the answer here, it's 120 billion events per day. And they were able to do that in 4 hours to ingest all those so that they could take action on them instantaneously and understand what happened. That's cool, but what's cooler is that they did it with 6 developers in 6 weeks using the platform. And that's speed to market in a very disruptive fashion without having to buy one physical piece of infrastructure to be able to do that. Citadel. Citadel's been a longtime customer of GCP. They run Monte Carlo simulations, and they burst into the cloud every day from 30 to 60,000 different amounts of cores. They compared leveraging GCP to having access to the largest supercomputer in the world whenever they wanted it. They're able to run simulations that they could only afford to run once a quarter or once a year to multiple times a quarter because it's so cheap for them to be able to do that. Right? And that's the insights that they're trying to provide. Lloyd's, this is a little bit of a different example. They knew that they needed a digital analytics platform, and they wanted to get better insights into what their customers were doing, but grinding through all that data took a long time, and time when you're trying to respond to a customer demand or opportunity is very, very costly. And they were able to go from 96 hours to 30 minutes to be able to act upon that, leveraging the cloud. So we're gonna talk about, I'll just kind of sum this up in the 5 different areas that we see a lot of trends with financial services and machine learning. We talked about the quants, right? Hippos, that's a good one for you to take home. Robotic Advice, being able to understand and provide recommendations internally and externally, right? You're gonna hear from a customer here in a minute on fraud and anti-money laundering. That's a big opportunity for machine learning because it can happen so fast and it can continue to learn. Surveillance, I'll talk about that in 1 second here too. And then customer support. I was with a customer recently, and what they wanted to be able to do is in their call centers, have speech to text using the Google speech to text API, take it to text, put it into a machine learning algorithm, make recommendations, and in sub-second response time, provide prompts to the CSR to say, your customer needs this, you should recommend that, right? The time that it used to do that is, immense. And now to be able to do that real time, right, with our customers is what the power is here. And that's the change. Let's move on to Madison APNIC. We've been working with Mercedes for a while, and Mercedes wanted to be able to have better analytics in their market data. So if I was to go to Mercedes.com and I should do this. I don't have a Mercedes, maybe I should. If I was to go to Mercedes.com and fill out an application for a loan, and I stopped halfway through it, and then a week later I Googled new cars in Chicago, and it came back, they could bid because they knew who I was on that ad, and they'd be willing to pay 5x the cost because they knew that I was interested before. But that ability to do that with machine learning makes them spend money in a really smart way versus just buying all the ads for everybody that wants to buy a new car, right? Now they can say, well, Kris actually went through the process of filling out the app, therefore he's a high potential, not the highest paid person in the room, but a high potential user or high potential buyer. Let's move on to Main Street. Has anyone heard of Babelfish? Babelfish is to be able to do foreign language conversion. Here's an interesting use case that I never thought I would see. On Monday, I was in North Carolina at a furniture company touring they gave me the tour, which is always a cool thing to do when you go to see customers. So they put my hard hat on and they drove me around the manufacturing floor and they showed me how furniture gets made, which it's a very manual process for those that don't know. But half of their staff is from Burma and the other half is from local. And the two can't talk. Can you imagine a world where using real-time speech language conversion that the Burmese and the local people could talk, right, fluidly and reducing the complications that could happen? That's what machine learning can provide in deep learning. Facial recognition. It's an interesting picture. How is that applicable here? We talked a little bit about security. And having a security be able to be, when I badge in, it's interesting, but I could have just stolen someone's badge. But if I badged in and it knew that it was me as well, I mean, that's multi-factor. Or if I'm walking around the building and it says, Kris shouldn't be in this part of the building because he doesn't have access and to trigger an alarm using surveillance and video, that's an interesting model as well. So I'd like to spend a few minutes, hearing from me, I hope you enjoyed it, but hearing from our customers is also important too. So I'd like to hear, we'll just take a few minutes to hear from Daryl West, the CIO of HSBC, and how he's leveraging technology.
We are living in a time of rapid digital change, where the only limits are the scale of our ideas and degree of our dedication. The technology ideas of today will be the intuitive habits of tomorrow. Never before has innovation promised so much, touching so many in so many different ways. Our frontier is financial technology. It's changing the way we work, make money, and the way we trust each other. To succeed, we need to adopt the mindset of the Silicon Hubs of the world and create an incubator of free thinkers, thought leaders, innovators born of collaborative spirit, all fueled by a belief that technology will enhance our customers' financial lives. To imagine a future beyond what we already know, creating a team with the power to transform the world's leading financial enterprise. We are technology.
So the history of enterprises like mine is that we typically did extracts into traditional data warehousing platforms, which worked well for many years, but of recent times have become expensive to run and difficult to use. So we took the plunge about 3 years ago to really embed ourselves into the evolving Hadoop ecosystem. And for an organization like mine that has this traditional history of what we call legacy platforms, it's been a tough road for us. All of this has been done on-prem. We've had to provision large infrastructure, physical infrastructure, build out data centers, and hire talented new people that have understanding of these new technologies. So we thought about this very carefully in the last year, and we said to ourselves, well, really, we're a bank. At the core of our business, we're a bank, but we also have a significant technology company embedded within the organization. And the question that I was asking the management team is, do we really want to compete with the cloud providers and people like Google? Are we really going to try and do what they do as well as they do it? And I think our conclusion was that it was better for our business if we adopt a cloud-first strategy. So we started working with Google about 6 months ago now, so it's still early in our relationship. But we've been working with them on some of the most important and critical business problems that we have to solve in our business. To give you an idea of what these types of problems are, so the initial use cases here are typically characterized by business problems that have very large data sets and require very intense computing capability in short bursts. Now, the first one on this list is all about anti-money laundering. So as one of our obligations of being a bank, we work with the government and the crime agencies to identify nefarious activity and money laundering, criminal activity. Now, we have a set of applications that monitor a huge time series of data, so a massive data set, billions of transactions for all of our customers. And we're running analytics over this huge data set with great compute capability to identify patterns in the data and to bring out what looks like nefarious activity within our customer base. And those patterns that we identify are then escalated into the agency, so we work with them to track down the bad guys. So this is an application that clearly requires massive data sets, great computing capability, but also a machine learning capability to be able to identify the patterns in this huge data set. The other applications that are mentioned here in terms of finance and risk, we have billions of transactions. Those transactions need to be aggregated so we can manage our finances and our risk at a global level. Evaluation services in our trading business. As I said, we're a major player in global financial markets. We need to be able to run complex Monte Carlo simulations on a regular basis to be able to better understand our trading positions and our risks. So this requires a significant compute capability. So we were faced with the question of, do we build out a new data center and put thousands of servers and thousands of cores out there to do this activity, or should we actually work with somebody who does it as a core business? And our conclusion was, rather than build it out ourselves, we should be working with world-class leaders in this space, and hence our work with Google.
So with that, I just want to say thank you. Thank you, everyone, for your time today. Enjoy the rest of your conference, and have a great weekend.